Welcome to the video for Section K for the AP Summer Packet, and Section K is on exponential equations. Okay, so these are equations in which you have a variable inside of an exponent. These are equations that are usually going to require you to use a logarithm to help you solve them. So let me do a couple examples similar to the ones that are in your packet to help you out. So here's a problem. 3 to the x minus 2 power equals 18. Now again, the reason why we call these exponential equations is because in the exponent on the left-hand side of the equation, we have a variable. We're saying 3 to what power basically gets you 18. Okay, now if the 3 and the 18 were both powers of the same base, this would be an easy problem. We could just rewrite them as like bases and set the exponents equal to each other. We did that a lot in Algebra 2, for those of you that had me in Algebra 2. We can't do that, though, because I can't write 18 as a power of 3, and more often than not, that's going to be the case where we're not going to be able to rewrite with common powers. So the method that's going to work every time is by rewriting this equation by taking logs of both sides. So now we'll do the log of 3x minus 2 equals the log of 18. The reason why we do that is there's a property of logs that says when you take the log of an exponent, you can move that exponent out in front and treat it like a coefficient. So now we have x minus 2 times the log of 3 equals the log of 18. This looks messy, but it's actually not that bad to solve. We want to get the x right here by itself. So the first thing I want to do is I'm going to divide both sides by log of 3, because that's just a number with a really weird decimal value. Now I have x minus 2 equals log 18 over log 3. Could you go to your calculator and get a decimal? Sure. On the AP exam, however, they're going to probably want to see exact values, so you don't really have to get a decimal. I know in the directions I tell you to round to 3 places. That's fine, but realize you don't actually have to do that. I will do that in the example problems, but I'm also going to show you where the exact answer would look like. To get the exact answer, the last step would just be to add 2 to both sides. Be careful where you put it. It's not part of the fraction. It's just going to kind of go out to the right of the fraction. So the exact value of that equation is x equals log 18 over log 3 plus 2. Now if you go to your calculator and type this in, and be sure to type it in correctly with parentheses around the log 18 over log 3, you would get x is approximately equal to 4.631. I'd accept either one. This one is the exact. This is an approximation. And we like to be as exact as possible. So like I said on the AP exam, this is good enough. Let's look at a couple other ones. Let's look at one that has an e as a base. E to the 3x plus 1 equals 10. Okay? Remember, you may have seen e before. I know you have in Algebra 2. E is a number, just like pi. It's a number that represents an irrational number. It's a letter that represents an irrational number. When we deal with exponential equations of base e, we're going to do the same approach, but instead of using log, which has an implied base of 10, we're going to use the natural log, because the natural log goes hand in hand with e. Because if you remember, the natural log is just a log of base e. It's going to make the algebra here a lot easier. We're still going to use that property where the 3x plus 1, the exponent, can come down. But the natural log of e is just 1. So we get 3x plus 1 equals the natural log of 10. And then we can just peel back the equation to get x by itself. We'll subtract 1. So we get 3x equals the natural log of 10. I'm putting parentheses around that 10 to remind you that when we go to the calculator, we're doing the natural log of 10, and we're going to take that answer minus 1. This is not the natural log of 9, something totally different. We'll divide both sides by 3. So x in its exact form is the natural log of 10 minus 1 all over 3. But if you so choose to type that into your calculator, and be sure that you do it correctly with order of operations, that has a decimal approximation of about 0.434. Let's try one more, one where we have variables and exponents on both sides of an equation, something a little bit tougher. How about an equation like this? 2 to the x equals 3 to the x minus 1. Okay, approach is going to be the same. We're going to take logs of both sides. So now we have log of 2 to the x equals log of 3 to the x minus 1. We'll bring both of those exponents out in front of their respective logs. So I get x log 2 equals x minus 1 times log 3. Now, think back. I know this looks really confusing, but think back to what you did in Algebra 1 when you had equations that had variables on both sides. Your goal was to get the variables all to the same side. We're going to do the same thing here. So here's how we're going to do that. We're going to take the x minus 1 in parentheses and we're going to distribute it into that log 3. So now the right-hand side is going to be x log 3 minus log 3. Okay? Now I see I have two terms, one on either side, that contain the variable x. Let's collect them. Let's bring the x log 3 over to the left. Now I have x log 2 minus x log 3 equals negative log 3. And with that, we're almost done. I can't really combine these two terms because one has a log 2, one has a log 3. And we can't really subtract logs the way we subtract regular numbers. Instead, I notice that they each have an x, so we can treat that as a GCF and factor it out. And that's the key. Because now I have x times this really weird-looking number, log 2 minus log 3, equals negative log 3. I'm just going to divide out by that weird-looking number of log 2 minus log 3. So I'll write it cleanly up here. That means that x is going to equal, in its exact form, negative log 3 over log 2 minus log 3. If you go to put this into your calculator because you want a decimal instead, that would be something like 2.710. Okay? So this is how you would solve some exponential equations, how you would take logs of both sides, use properties of logs to solve some exponential equations. Very important. Next year we are going to do some things with logs and natural logs throughout the course of the year, so be fresh with knowing how to handle those. Okay? Thank you very much for watching, and best of luck as you move forward in the assignment.